Hello and welcome to Technical with Kranti. And in this video, which is the fourth question on recursion, we'd be finding unique subsets that sum up to k. In the previous video, we have seen the subsets that sum up to k. Now we are finding unique subsets that sum up to k. But before that, let's look at the thought for the day. All right. So these many questions we have done in the recursion. So let's look at the question. You are given an array, find the unique subsets that sum up to k. So for example, if this is the array and the target value k is 2, then what do you think is going to be the answer? It would just be 1 1. That's it. Because there could be multiple 1 1 1 1 subsets that can come out, but we just need to report the unique subset. Okay, so how are we going to do it? Before seeing how are we going to do it, I'd just like to remind you that we have done similar kind of work in the previous videos. So in DSA 4.2, we had to find all the sums of subsets of the array. Here we are not talking about unique subsets. We are just saying whatever different sums that you can obtain, just find them. In 4.3, we were finding unique subsets of the array. In 4.4, again, it was similar to 4.2. Find subsets that sum up to k. And in this video, which is DSA 4.5, we have to again find unique subsets that sum up to k. So finding the unique subset has one kind of approach, and just finding the subsets has one kind of approach. And the detailed comparison of these two approaches I have explained in DSA 4.3. So I'll not do the comparison, I'll just go on to explain how are we going to find the unique subset. For detailed explanation, you can refer DSA 4.3. So this is the array that we have. All right. So to begin with, we'll have a null set and an index 0, which would serve as the basis of the first recursion. So in first recursion, the index would be starting from 0 and will go till 1, 2, 3, 4. All right. So at 0, we'll have 1 in the subset. We'll include this element. And the next index would serve as the basis for next recursion. Now, this particular one is a repetitive element, so we'll not take it. Again, we'll not take it, we'll not take it, we'll not take it. So for this index is equal to 1, 2, 3, 4, we'll not be considering these elements because these are repetitive. At the first position, I cannot consider the same element again. So recursion will drop over here. Over here, the index would start from 1 and will go till 4. At 1, I have this element. So f of 1, 1. Okay. And the next index would be 2, which would serve as the basis for the next recursion. Again, we have we have seen that for I equal to 1, I have included the element, but starting from I equal to 2, these would be repetitive elements for this level. So we'll not be including these elements at this level. Again, going further, I would arrange from 2 to 4. At 2, I again have 1. So my subset will become 1, 1, 1. And the next index for recursion will be 3. For I equal to 3 and 4, these would be repetitive elements at this level. So we'll not be considering these two ones at this level. Then similarly, at subsequent recursion, we'll have this subset and the next index would be this, and I'll have this particular subset at the end, and there would be no more recursion because we are done. So This is one subset, this is one subset, this is one subset, this is one subset, this is one subset. So I have in total 5 unique subsets out of this array. And at each level, I'll just calculate the sum. And if sum is equal to the target, I'll include it. I'll include it into my answer. All right. So let's have a look at the code implementation. So this is the code implementation, and this is our array. To begin with, the index will be 0 as we are starting from here. Index would be 0 and st would be empty. So sum will be 0 and target. What was the target? Target was 2. So these two conditions will not be hit. I'll start from 0 to n, which is the length of the array, 0 to 5. This condition I've explained in DSA 4.2. I'll again explain it. So array of I equal to array of I minus 1 is used to check the duplicacy. But this check needs to be done only after the first index, right? So in every recursion, the loop will start from index and go till n. So what I'm trying to say is, at this level, ind is 0. Ind is 0, correct? So duplicacy check will start from the subsequent index, correct? At this level, ind is 1. So the duplicacy check will start from 2, because the first element can't be duplicated at any level. The duplicacy can only begin from the second element onwards. That's why this particular check is introduced. So if there is a duplicacy starting from the second element onwards at a particular level, then we'll not be considering recursion for such elements. We'll not be considering those elements. Otherwise, go to the next element, including the current element into the subset, right? Finally, since we have sorted the array, the sums that we'll be obtaining would be increasing or non-decreasing, right? So once the sums begins to go greater than the target value, we can return. But more important base condition is this: if the sum of the subset is equal to the target, include it into the subset and return. So similar algorithm was explained in DSA 4.2 as well. So that's how we create unique subsets. We check the sum is equal to target and we include it. So I'll submit it and let's see. Yeah, it is accepted. So I hope you understood the question, the approach, and the Python implementation of it. If you did, please consider subscribing to my channel and like the video. Thank you. Bye bye.